In this video, we will discuss the application of operational amplifier. One of the application of the operational amplifier as your inverting amplifier. We will discuss what are the questions from the inverting amplifier, and we will also discuss about the theory of the study of IC 741 as inverting amplifier. We will do the experiment in the next video to study the operational amplifier IC 741 as inverting amplifier. We will do it in a separate video, but the theory of the operational amplifier, that is the inverting amplifier IC 471, we will discuss. In long question section, you will find this type of question, so that the closed loop voltage gain in inverting operational amplifier is the ratio of the feedback resistance to the input resistance. This is a long question, and short question also come like this: why the closed loop voltage gain in inverting operational amplifier is negative? We will discuss this type of questions in this video. This is the basic circuit diagram for the inverting amplifier. This is your inverting end, that is the negative end is the inverting end, and positive end is the non-inverting end. In inverting amplifier, the output voltage is inverted with respect to the input voltage. This is the output voltage. VO is the output voltage, and the supplied voltage V1 is your input voltage. And in case of inverting amplifier, the output voltage is inverted. The shape of the signal will be inverted, or it will be negative with respect to the input voltage. And the input voltage in inverting amplifier, the input voltage is given to the negative terminal of the operational amplifier. The input is given to this negative terminal. Here I have taken V1 is your input voltage, and V, this is your voltage at the inverting input, and VO or V0, whatever you write, this is your output voltage, and G is the virtual ground. I have discussed about virtual ground in previous video. You watch the previous video what is virtual ground. And here R1 or RIN, you may write R1 or RIN, that is the input resistance. This is your input resistance. And RF, this is your feedback resistance. You have two resistances, input resistance and feedback resistance. Now you see current passing through this input resistance is equal to I. This current is equal to I. And if you have a ideal operational amplifier, then the input resistance is very high. Input impedance is very high, that is infinite. I have discussed it in the previous video. Okay. If the operational amplifier is ideal one, then the input impedance of this operational amplifier is very high or infinity. So no current passes through the operational amplifier. That is why the current which passes through this input resistance is equal to the current passing through this feedback resistance. And what is the current passing through this input resistance? Current is equal to voltage divided by resistance. So the voltage is equal to V1 minus V. The difference in potential divided by the resistance, that is R1, that is equal to current passing through this input resistance. And what is the current passing through this feedback resistance? Current passing through this feedback resistance is equal to the V minus V0 divided by RF. Is not it? So current passing through this input resistance is equal to how much? V1 minus V divided by R1, and current passing through this feedback resistance is equal to V minus V0 divided by RF. So these are the things we have discussed. These are the things: what is V1, what is V, what is V0, what is G, what is R1, what is RF, and what is the current through the resistance R1, and what is the current through the resistance RF. So you take you have two equation: current through this resistance R1, and another equation is current through this resistance RF or feedback resistance. Using Kirchhoff's current law, in Kirchhoff's current law, you have the incoming current is equal to the outgoing current. So V1 minus V divided by R1 is equal to V minus V0 divided by RF. And G is the virtual ground. And in virtual ground, the voltage is equal to 0. Okay. It is not actual ground, it is virtual ground, and the potential at the virtual ground is equal to 0. I have discussed it in the previous video. So if you put V equal to 0 here, then you have equation V1 divided by R1 is equal to minus V0 divided by RF. So what you will get, V0 divided by V1 will be equal to minus RF divided by R1. And what is V0 divided by V1? That is the output voltage divided by input voltage. And what is the ratio of the output voltage to the input voltage? It is the gain. Okay, this is the gain of the operational amplifier. So the gain of the operational amplifier is equal to the ratio of the feedback resistance to the input resistance. So the closed loop voltage gain, this is the closed loop voltage gain because the loop is closed by the which resistor? Feedback resistor. So the closed loop voltage gain is the ratio of the feedback resistance to the input resistance. This is a question. This theory, this theory you have to deduce in long questions. And you see, this is, you have a negative sign here. Negative sign shows that the output voltage is inverted with respect to the input voltage. That is why you have negative sign. And in the experiment to study the operational amplifier, that is IC 741 as inverting amplifier, you have to prove this equation. You have given the input resistance value and the feedback resistance value. The input resistance and feedback resistance value, it is given, and you only measure the input voltage and what is the corresponding output voltage, and you will verify that the ratio of the output voltage to the input voltage must be equal to the ratio of the feedback resistance to the input resistance. You have to verify this. If this is equal to the gain, you calculate in terms of output voltage and input voltage, that will be equal to the ratio of the feedback resistance to the input resistance, then your experiment is over. This is how to study the operational amplifier as inverting amplifier. You will show it in experiment. And in theory you will ask questions like this, so that the closed loop voltage gain in inverting operational amplifier is the ratio of the feedback resistance to the input resistance. So in long questions, 4-mark questions or 5-mark questions, you have to show this relation. This is the closed loop voltage gain in inverting amplifier, and which is equal to the ratio of the feedback resistance to the input resistance. You have to prove this formula. Then you have also short questions in the examination. Why the closed loop gain in inverting operational amplifier is negative? I have discussed here. The in operational amplifier, the closed loop gain is negative because I have written here the output voltage is inverted with respect to the input voltage. Since the output voltage is inverted with respect to the input voltage, that means if you have input voltage like this, then the output voltage will be like this. It will be inverted. So I have written here, since the output voltage is inverted with respect to the input voltage, that is why in closed loop voltage gain of the inverting operational amplifier, it is negative. So this is the one application of the operational amplifier as inverting amplifier. In the next video we will discuss about another application of operational amplifier, that is non-inverting amplifier. If you are satisfied with my videos, then please like, share and subscribe. Thank you.